Hello. Around. Hello. So far, just you and me. Greco, hello. Olix, hello. Oh, it's been a long weekend. I feel like I have an excuse every time I stream, but this time I also have an excuse. Betty, hello. Been a long weekend. Jolt is the physics engine du jour for us. Julian, hello. Connor, hello. No worries. We'll. Doesn't matter how late you join this stream. I'm skeptical how much we'll get done. There's a lot of boilerplate to do. Indeed, one must physics. Costless, hello. I'm gonna crib a little bit off the previous project, but there's some stuff I want to throw away and rewrite, especially around the character controller and maybe some of the abstraction stuff. So my aim today is to just try and get something working, even if we won't see anything, but at least like it wired up and running, and we get like a tick per an update per tick. Hello, hello. Hello. If you're from Chechnya, and apologies if I mispronounced that, that is where the next WG21 meetup is happening next week, which is exciting. In Borno. Borno. Yeah, I think like we can just get like a plane. The problem is that I think even that is going to be quite hard because we're going to have to create the whole character controller, which I think might bleed into another few streams. But let's just see what we can get going. I'm attending remotely next week. Okay, let's think about getting started because I did a little bit of work off stream because I had a little bit of time. Let's see, where are we at? So let me just commit this circuit. Integrate. Oh, sorry. So I've added Jolt as a I've already added Jolt as a dependency, so shouldn't be too surprising. I literally just copy and paste it from the last project. It does fetch content declare, builds the library, wires it all up, bish bash bosh, easy peasy. The other thing is I finally had a go at refactoring some of the debug renderer, so it's a little bit nicer now. Basically, the way it works now is, so we have this normal setup chuff, and then we have a bunch of helper functions like create debug window. So the root of this all is this new create debug controls, which takes some, it all works on structs now. So you give it a struct, and then it will reflect out of that struct the individual members, and then it will create in-GUI widgets, controllers, whatever you want to call it, for those individual members. So if you give it like a float and a color and whatever, then you'll get all those various parts. This was good fun. Part of me thinks I should have done this live, but also it was kind of fun just to sit down and just write some C++26 just quietly by myself. So you give it a thing, and then it reflects them out, and it creates here's the individual type. So texture, this will render a little image, plot. So I've got kind of quite relatively fine, like coarse-grained things. So you can give it a log view, you can give it a duplicate entry, which will just render the button to duplicate the entity. You can give it a matrix 4. They're kind of various degrees of abstraction, just because it makes it quite easy. So there's a bunch of custom types I've got at the top. Like, so if you want to render a same line, you just give it a same line, and then it will render it. Or a log view, plot, various buttons that do things, add lights. So you can kind of just compose these, and then the create debug window, basically you give it a whole load of structs, and it will create a window for those. So this is the whole left window we see now is all encapsulated by this. You can see that it's got the basic scene info, because you can just declare inline structs, right? So for the luminance, I just have a struct which is the average luminance in this special histogram object, and then I shove that in here, and then it reflects out and builds it. So I kind of gave up about here, and this is still the old code because I just ran out of steam and it was a little bit gnarly to kind of do, but makes life a lot easier. It's super easy now to adjust this. The other side quest I went on was like, so you want a slider in ImGUI, right? Like, which is really not an unreasonable thing to want, right? So say all my floats, like if they're non-const, I want them to be a slider. So all the SSA options and the bloom options, I want those to be sliders, right? But I need a min and a max because I have to know like what to set the minimum and the maximum of the slider value is. So you could just pick some, like the smallest of all the small values that you're ever going to need and the largest of the large values you're ever going to need, but that's a bit lame. You could try and heuristically work it out based on what the default value is, but that also seems a bit lame. So instead, I spent a couple of evenings writing a bounded number class, which is templated on a type with a const compile time minimum maximum, and then all the operators on it. So this will basically behave exactly like, so for instance, bounded float will behave almost exactly like a float. It's a drop-in replacement for a float, but you can do all your regular arithmetic on it. You can dereference it. Sorry, you can get the address of it. So you can do all that kind of gubbins, and it just kind of works. And this was like, I had so much fun writing this. This was good fun. If you're interested, check out the code. It's kind of some nice modern C++ stuff in here, and also kind of just a bit of like there's a lot of boilerplate stuff in here, which are basically kind of interesting if you've never kind of done it before. It's a spaceship operator. So yeah, so now if we go to scene, we now have like tone map options is a bounded float for max brightness between 0 and 100. Have you got comparators to the underlying type? Yes, I think so, because you can, I think I use my trick of having the non-explicit constructor, so it will automatically convert that type to the bounded type with just a min and max, with just the largest min and max. There's a bunch of tests for it as well. There's loads of tests. And so for instance, like sample count, sample has between 1 and 64, and then this automatically reflects it out, pulls out those bits, and then creates the slider for it. So this works out quite nicely. Also, because it's all compile time and const expert, if it will fail to compile. If it can evaluate it at compile time, it will fail to compile if you give it a value that's too large. Otherwise, it kind of falls back to runtime. Use your class bounded float, but always use the default numeric limits. I mean, I'll just tweak them as I need them, right? But yeah. Spear v shaders, nope. They're just .frag and .vert, and then they just go into the OpenGL compile hole. Okay, so that was a bit of fun, right? So what we want to do today is Jolt. So I've got some of the old code from the last project, kind of off screen. So we're going to kind of slowly work our way through bits of that. But I also dusted off my really old version of Visual Studio because I never use it, and I built the Jolt samples. So if you can see that. How does one menu? Physics. I literally had select test. There we go. Character. So there's different types. There's character and character virtual, and I think we want character virtual. I think character is for like NPCs and stuff like that, whereas character virtual is the one which does all the what you actually would expect from like an FPS. So if we load this up, you'll have to bear with me because WASD don't do what I want it to do. I have to use the arrow keys. Oh, hang on a minute. WASD moves the camera around, which is not quite what I want. So I have to, but my keyboard doesn't have arrow keys, so I have to hold the FN key and then move it around. So it's not particularly ergonomic, but this is kind of what we want. So we want to push stuff over. We want to be able to interact with moving objects. Oh, I got stuck. Oh, that's interesting. And then you should have like objects which I cannot move, but can move me. Ugh. Sorry, this is really not ergonomic. Anyway, so this is kind of what we're going to recreate, right? And then, so we've got some code for this, which is nice. I think there's a jump key, but I can't find it at the moment. And then I want this idea that you can have sort of, we're not going to need it, but it's nice to know there's kind of this concept of maximum slopage as well. So yeah, that's the plan. Is to we want one of these. We want one of these. So get rid of VS Code. Don't need that. Oh, so not even VS Code. Visual Studio. Let's make a Mukta source physics. Right, off to a good start. Source physics. Physics system.h. So namespace. Oops. Right. So last time we used Pimple because there's an awful lot of headers and gubbins that are kind of required for this, and I'm in Windows cut off. I don't think it has anything useful, but I'll move that up. Sure. I think the reason I did that is because then you don't have the green bar. I don't know if you really need to see my tmux bar, so I might leave that as this for now and just see how we get on. I'm in two minds whether to go back to doing the Pimple one, because one, it's kind of good education and it's useful technique and it does kind of move all our implementation detail into the CP file, but on the other hand, do I need it? I think the thing I need to check is, do we use it everywhere? So where we have like the rigid body, no, okay, that's fine. So I was concerned because what I don't want to do is have force a dynamic allocation, which Pimple effectively requires you to do for like the primitives that we're going to produce. But at the same time, like if I've got all the jolt headers here, like, and I'm going to be giving out this type, like what's the point of having the Pimple idiom in the main one? So I might try not this time and then just see how we get on. Because we control all the code anyway. All right, nailed it. I don't even make any of this context, bro. I don't think Jolt is context, bro. Okay, so let's do physics system. We want one of those. Physics system, const, physics system, delete, auto, operator, const, physics system reference equals delete. I guess, I don't even know if the internal types are movable. I don't really know how Jolt's programmed. I guess it would be impermanently movable if we had Pimple. Tempted to make this not movable as well. Like you just create this and pass it around. There's kind of no need to be transferring ownership of the physics system around. I might live to regret this, but we've got to start somewhere. Guess we're rule of fiving. Okay. And then we're going to want some sort of auto update. That's kind of what I'm thinking. This is kind of what I'm thinking. Something like this. And then if we go back to our physics, what we did last time, which I'm going to slowly crib Ofcom. We have to have all this gubbins. We need a broad phase layer. We need a object versus broad phase layer filter. Don't forget that. Object layer pair filter. And I'm going to try and remember what all these do as we go through them rather than just blindly copying them. A temp allocator. So this here is interesting because I'm going to start off with this, and then it's going to be a future change to write our own thread system pool object, because I think you can subclass this that uses our existing thread pool object. So I'm going to kind of allow this to spin up its own threads, but that's going to be quite a short-lived level of control that Jolt's going to enjoy, because it should really use our job system. But it's just too much to get going for now. Sorry, it's just too much to be doing for now. I want to kind of get it going, but I want to investigate like how we can replace this. We need the physics system. I can't remember why I have this. That seems strange to me. And then we got to do the debug render as well. And the character controller. So quite a lot to do. I think basically, oh god, I wrote comments. So go set up chuff we have to do. That's fine. And then basically what I'm trying to do is I want to get to this, right? And then this. That's my goal, is to get that running. We won't see anything. We won't even know it's happening, but it won't, as long as it doesn't crash. And then we can start to add functionality. We can start to add the shapes, the rigid bodies. We can start to add the debug renderer, that kind of thing. So that's kind of my rough plan, is to relive some of this. So let's go with source. Let's see if we can get this actually building first. Namespace of physics system. Probably all we need to get going. And then VS. Sorry, no. Copy. Source graphics CMake to source physics. And this is going to have physics system. Let's stick this in the CMake hole. MNOPQR physics. All right, let's just. Computer, hello. I think this is loading resources. I think that's what someone was asking last stream, like why is this taking so long? I mean, one, it's my terrible code, but two, I think it's loading resources. So anyway, we should see now that all these things here are all basically as they were, but they've got nice little headings now because it reflects the name of the struct out and says, like, here are your tone-map options, here are your SSAO options, which looks like so options, but sure, bloom options, and then these should all work, right? Cool. Okay, right. So we're gonna have a bit of a decision to make at some point as well, especially around like the pipeline of like asset pipeline. In the previous game, I just took, because it was like one small level, like literally a warehouse, I took all the meshes and I just bunged them into Jolt's mesh collider, mesh shape, which kind of worked, apart from that weird pillar issue. But I think that's really not kind of correct, because it's incredibly intensive. And also, if we're writing a proper character controller and this, this spaceship, it might not necessarily have a flat floor, there might be like little bits of like geometry on the floor and stuff. You don't want to be like bouncing all over those. So we'll need to have some sort of proxy shape for the physics interaction. The correct answer is to take every single model and then somehow, I don't know, maybe in Blender or something, create the proxy object and then store it in like a YAML file or something like that, so, or some other file, so that I can, every time I add a new object, I instantly get the proxy shape. I don't know if I have the effort or the inclination to do that. So what I might end up doing is, right, it might be easier for us to be able to use the UI editor to create very simple physics primitives like planes and boxes and spheres and cylinders, and then just drag those around as we create the map. I'm probably going to start with that because I think that will actually get us where we want to quicker. How you do stuff with like holes in and stuff, if you want to have like a door, I guess you have more objects, but that's where I'm kind of, my mind is going to start with. But yeah, we'll see how. If it's a massive pain, maybe I'll just pay the price and spend a few evenings in Blender, which I really don't want to do because I don't like Blender. As in, like, I don't like 3D modeling is just not my thing. Do I think reflection modules will work together with the version of the compiler you're using? It's kind of like, there's kind of like a two-part to that answer. Like, one, like reflection definitely works with this version, and I think it's got better module support now, but it doesn't work with MinGW, which is what I'm using. At least modules doesn't. Or when I last tried it, I couldn't get modules to coalesce with MinGW and my ClangD. So maybe if you have a sensible environment, yes. But I struggled to get, when I was setting up the project, I struggled to get a smooth and cohesive dev environment, which I really wanted for this sort of scale of project. So I had to sack off modules, which is a bit of a shame. I am determined to try modules and commit to it for at least one project. So next project, I will give it another go, and hopefully the tooling's moved on a little bit by then. Right. Anyway, I am gassing and not coding. So physics system. So let's do. I also need to do auto physics system update void. Right. Ain't gonna do nothing. And let's go main, and let's start to bring this in. So hash include physics system. I'm going to create this after the thread pool because I suspect eventually I will need to pass it in to the thread pool. Sorry, I will need to pass the thread pool into it. So let's do. I'm probably going to need to pass the debug render into it as well. So let's do like here. Let's just call it physics. What do I think of Apple Metal? I like ARM. Seems nice. I don't use a lot of. I used to use quite a lot of Mac stuff. I mean, I have an iPhone, but I don't really use like their desktop stuff anymore. AC still here, still resubbing. Can't get rid of him. W emote. Is that some sort of Twitch nomenclature I'm unaware of? So let's see. What's the correct order of things? It's probably to. While running, it's probably handle the events, then the physics, then it's probably handle input events, sorry, then physics, then schedule tasks, then render, I think. We'll see what happens. It's built. I don't know why it's taking so long to link the unit test. It's a little bit upsetting. I don't have a lot of experience with DirectX 11 and 12, so I can't really offer you much of an opinion. Like, I think they're probably fine. Like 12 would be complex, like Vulkan is. Oh, sorry, you meant Apple Metal as in the graphics API. I thought you meant as in like sorry, I read that in my mind as Apple Silicon, as in like what do I think about them with their own like hardware and stuff. That's why I said I liked ARM. Metal I've used before. I actually think out of the sort of the modern gen APIs, so Metal, DX12, and Vulkan, I actually think Metal was it felt like the most approachable when I was kind of playing around with it. Sorry, apologies, I misunderstood your question. Yeah, I thought Metal was kind of all right. Obviously, you got to use. Well, I used Objective C++, which is an absolute, which is an oddity unto itself. But yeah, it was all right. I felt it still kind of gave you enough help to kind of get to where you wanted to going, but I didn't really explore it too deeply. Objective C++ is weird. It's also the reason we have the double carry for the reflection operator. Right. Possibly, yeah. I looked at it quite a while ago. Okay, right. So that seems. I might like commit that. So like initial physics system setup. Excuse me. Right. Now I need a whole bunch of gubbins. So let's have a look what we got. We need the broad. So these are my own objects, and I think you have to supply your own. I don't think they have like a basic implementation. So let's have a look at what they do. So we've got the simple broad phase layer, which is the broad phase layer interface. No backlighting. Might never. So it has to. Right. Okay. Fine. So Jolt has this concept of layers. Ogres have layers. Onions have layers. Jolt has layers. The idea that you say when you add something to the Jolt system, you say what layer it's on, and then you control which layers can interact with each other. So we can have. I don't really like non-moving. I think I might rename that to static. Shrek indeed. Great film. I realized how old that film, the first one, was the other day, and then made me feel really old. So we can have like the static and then the moving one, and then you basically have to tell, because the layers are for you to decide. You decide how many layers you want and what those interactions are. Jolt doesn't have any opinion on them. It will just, okay, Jolt has the concept of layers, which are used to filter collisions. These are the hard-coded layers that are used in the game, right? But you have to tell Jolt about those. So I have to say, hey, this is the number of broad phase layers there are. And then given a special Jolt object layer, right, object layer object, I have to convert that into a broad phase layer, right? Which I think I then just cast it. I think that's what I'm doing there. Yeah. I can't see that on my chat, on my tool, I'm afraid. Nice. Okay, and then I have to, if we're using, I don't know why I have this, because I really hate macro. Gone. Absolutely gone. Apparently I need this. Get broad phase layer name. Oh, mate, we can reflect that out. What are you doing? Just reflect that straight out. That's crazy. I remember Pokemon Red when it came out. No, not when it came out. Yeah, I think so. And then we have the simple object versus broad phase layer filter. One of my favorites. Very simple. I suppose that's what I named it. It just implements the object versus broad phase layer filter. Why is this? Jolt has some very interesting design decisions that I don't necessarily agree with, but you have to remember that I have not written a AAA physics engine, so I'm more than happy to cut them some slack, but I will point out the bits that I don't agree with. Why is this an interface and this not? Maybe this is an abstract class, or maybe it has some implementation in it. But either way, I have to override should collide. So basically what this object does is Jolt will say, I have these two objects, right, on these layers. Do I do the collision detection for them? So it's the object versus broad phase layer. So in physics engines, you have two passes, the broad phase and the narrow phase. The broad phase is it divides the whole scene up into a bunch of high level primitives like, I don't know, some sort of bounding volume, right? Some sort of bounding volume hierarchy, where those objects are cheap to test intersection, but are not fine-grained enough to tell you if they actually test. So when it does the broad phase, it will do those super quick calculations and create a short list of things that may potentially collide, and then it will do the narrow phase, which is the more expensive but actually accurate one. So this is basically saying in the broad phase, right, given these two layers, should I be even processing them? And I think I say basically, if either of them are moving, then yes, because I don't. There's no point it trying to do static intersection, because that's kind of meaningless. Do we have to add jolt stuff to our objects in that game? Yes. I've never used PhysX, so I don't have an opinion on it. Didn't have some sort of weird licensing turmoil or something on the barrel class? Yes, you might be right. And then we have the object layer pair filter. Why have I implemented this? This is very similar. Why do I need two of these? Object versus broad phase, and this is the object layer pair filter. But isn't it only certain versions of it are open source or something? I don't know. I've no interest in it. Jolt seems to be pretty cool. One is layer versus layer, the other is object versus. But aren't objects assigned to a layer? Anyway, apparently we need both. Like, that's their interface. I'm happy to conform to it. It's got ranges in there. Can't be that bad. Oh yeah, then this horror for tracing, and then yes, okay, we think we're there. So let's. Do we want to type this out? I think we should type this out. So let's do physics system. So let's do enum class physics layer. Okay, and then we're going to go for static, then we go for dynamic, then we go for max layer. So as long as everything sits before this, then we can always query effectively the number of elements in it. Oh, actually, do we even need that? Can we just reflect that out? Or is this old news now? Is this fake news in 2026? Can I think I can do stood meta enumerators of and then just get the size of it. So actually, might be onto a winner here. Let's give it a go. Let's go for broke. And then we need a bunch of these special objects that we've defined. I'm tempted to, I think I'm going to do source physics utils.h. Once. Nope, that's not how that works. In space, oofs. And then let's do source physics layers. I don't know what to call layers. Physics layers, yeah. H. Sorry, this is just my mad ramblings today. Have to put up with me for a bit. Yankety. Take that. Once name base ifs. Right. Pull that out separately. That helps us, and also we instantly can string this as well because we've got our formatter, which is nice. I think that's what we need there, so let's get rid of that, and I suppose we don't actually need that here yet, do we? Let's go to the physics utils. Hash include physics layers. Right, that's nice. Ooh. Will I ever do code reviews of viewers' code? So I've done one or two of these, which was really interesting. I really enjoyed it. There was just so much to do in this project, and I can only stream twice a week. I'm personally just incentivized to try and route through this, to try and spend as much more time on this project as possible. Maybe we could do like a bonus stream with that. That might be something fun, but I don't really want to derail this particular series. Does that make sense? Okay, so what's the broad phase? Oh my goodness, I forgot. Jolt has like... Right, so I've just noticed something I did before. I had to include... You need to include jolt.h, but that has to be... It's very much like windows.h. It has to be included before everything else. But because my client format automatically alphabetizes includes, because that really... It feels right to me, I have to have a new line and then all the includes, which means I can't quite technically group them all together. It's a little bit annoying. No, I don't talk. I try and keep my work life and I have three lives, right? I have a family life, a work life, and a YouTube life, and I try to keep them all separate from each other. My main role is teaching and mentoring like junior talent. That's about probably as much as I'm happy to kind of divulge. It's probably not too hard to figure out where I work. I just like to keep these things mostly separate. Right, so I want the what am I implementing? The broad phase layer interface. So that's going to be in the Jolt physics. You ready for this? Jolt physics collisions broad phase layer. I think that's where that is. And then we can now have class simple broad. Simple is my terminology, right? There's no reason it should be called simple. It's because it is a simple implementation. You could easily just call it broad face layer or UFPS broad face layer. It doesn't really matter. So Jupiter broad phase layer interface. Right, okay, so that gives us that. Let's do virtual. I'm going to try using auto for this because sometimes it goes a bit funny with it. But auto get num broad phase layers const override Jupiter. Nope. Steady, sound target. Jupiter uint. Function with deduced type. Didn't we have this last time? I can't remember. Does the override have to go at the end? There you go. Maybe that'll work. If overloading function needs to be set. Yeah, you see, I'm not convinced that's true, but we'll see what the compiler says. I think I might have just been putting the override in the wrong place last time we tried this. I could be wrong. Let's do return stud2 underlying. I'm also quite particular about my include groupings. I like it to be standard library, platform, third party, then project. Then we can do right, okay. I don't want to underlying actually at all here, do I? Because I want to meta at this. Meta. Let's do return. Actually, hang on. Right, yeah, let's try this. take one step back. I'm gonna range. Stud ranges size of stud. Yeah, include stud meta enumerators of physics layer. How do we feel about that? Platform include is like Win32 or POSIX, right? So Windows.h or Incontel.h or anything like that. I think that's gonna work for us. Let's try slapping that in, shall we? Hash include physics utils. We should be able to now have a private simple broad phase layer, and that'll be these, and that'll be our broad phase layer object. Simple is an abstract class. Yes, you are correct. I've not finished implementing it yet. At least it knows that. Right, so let's do virtual auto get broad phase layer. This is going to take a Jupyter object layer const broad phase layer override, and this returns, I think, the object layer. Harand, I'm with you there. I'm going to start growing chickens as soon as I can. I think there must be a difference between object layer and broad phase layer, and I wonder if they can. I wonder if those can exist separately. I wonder if you can have those as separate quantities, and then this is what translates one to the other. This seems to be what you're having, and what I do here is I basically just say keep them the same. So we might be able to have, because I was thinking about this, I think what I want to do eventually as well is I want to throw away my ray casting code and just use Jolt, because I think Jolt's picker or raycaster will be much more efficient than mine, especially if it has like the BVH and all that kind of thing. BVH, yeah. Bounding volume hierarchy, whatever. But if I'm just using proxy objects, I'll still need to upload all the mesh data, but I don't want to use that, as mentioned before, for the collision detection. So I think I can sit those on another layer and then just use those for ray intersection. Yeah, I think I can just shove it all into the physics system and just basically say don't interact with these. These are just here, and then only when you do the raycasting, just pick that layer. Is it me or is your camera flickering sometimes? You have to get more, like the whole screen, just the camera, the lights. So C++26, yeah, mate. Reflection, like this here. This is whoa. That flickered for me. This here, this C++26, like it's a whole new language with the reflection. Right, what am I doing? I'm kind of return static cast JPH. I think these are all alias, all type defs or usings for different integral numbers or integral types. So you can get the type, and then I just pop in the layer there. Yeah, UN8. Do I need to explicitly do JPH broad broad phase there. Okay, that might be enough now to get us to where we want to be. Let's see if that runs. I mean, GC 16, like the latest GC release supports it. Blah. Quat is supposed to be trivial type. Exclamation mark. I'm sure it is, mate. I suspect virtual functions are pure. Here we go, what's this? Cannot declare field broad phase layer to be abstract types. I think I must still be missing the broad phase layer name. Yeah, I think I'm still missing this other type. I don't know why it's in an if def. So let's do virtual auto const char star. Const char star. Get broad phase layer name. GPH broad phase layer oh, hang on, what am I doing? Const char star override. Okay, so what this does is this just, so we do const auto native layer equals physics layer layer dot get value. So what we do, we take that rando layer thing and then we munge it into our native layer type, and then we need to, it's such a pain, this, we need to return this as a string. The issue is, I'm gonna have to do a dynamic allocation on that, which is really annoying. The reflection library, where do we, let me find what I'm talking about. Formatter. Yeah, we can do identifier of. The problem is, sorry, I said that for a second there. The problem is identifier of returns a std string view, which we cannot technically get a const char star from because it's not guaranteed to be null terminated. So I think the correct, but then we're going to leak. Tricky. We might not be able to reflect this out because I can't think of a way that we can return a const char star that's guaranteed to be null terminated through reflection. Because we could munge it into a std string, which one was incurs a dynamic allocation. I mean, potentially, depending on the SSO, but that one should assume it would. But then that will go out of scope, and then we'll be left with a dangling pointer. There's no way of persisting ownership of this, and I'm also going to assume that nothing on the other end of this frees this. Debugging, I imagine, is what is probably going to be used for. Logging and stuff. Okay, fine. I don't think we have a choice, which is, it upsets me greatly to not reflect. We can use the C++23 trick of using enum those, and then that means we can just do static turn static dynamic. Which means if we add another one, we'll have to come and, we'll have to come and add it here. We will get a compiler warning, which means it'd be an error if we don't. Hang on, that's not how one C++ is. constant express store a char array for each enum value? Potentially, but I'm still going to have to do something per entry anyway, right? So I might as well just do this. This is easier. Yeah, it doesn't like what storing it somewhere else does that. I'm still going to have to manually write out the code for each one. But the point of reflection is that it doesn't matter how many items I add, the compiler just figures it out and adds it for me. Could I use reflection to const extra generate the lookup, if that's what you mean? Potentially. Hang on, I'm intrigued now. Quick side quest. Can I do static const extra lookup equals std meta enumerators of physics layer type 2 std views transform let's do auto e. So that would give me a std meta object for each. So each of these will be a std meta info. And then I do you should just do it with templates. But then it still doesn't help me, right? Because I still have to specialize it for each of them. I'm not sure. I'd have to think about this, but I'm on this side quest now. So let's do return std make pair of, I want the e to std meta display name of, or is it display string of? E std ranges to std unordered map physics layer std string Oh, it does not like my does not like me splicing there, does it? And then I can simply then do return lookup probably can't do that because it's const expert, so I'll have to do hang on, const expert auto find equals lookup dot find native layer const auto ensure find does not equal std ranges cend lookup could not find layer native layer return find second.c str. Just gonna, when this doesn't work, just gonna uncomment that. Nailed it. Look at that. That's modern C++ at its finest. In auto somewhere. Oh yes, good point. Okay, Alright, there's that blend. Let's see what horror awaits us from this. Oh, hang on, I'm missing a... I've seen that. That'll help. And then I will need to bring in hash include utils error. Anyone see it? Anyone see the error? It's done like this, does it? Why is it not like this? And stood ranges used. It might not like this constructor of string. Oh, hang on, aren't I missing a semicolon at the end of that? Nope, that's fine. Okay, there we go. It didn't like that. Would you not pass E into the lambda and splice in the use? So this... What do you mean? Is it display name of? Identifier of. Do I need to define static array as well? Hard drives used to be cheap, right? I used to say hard drives are cheap. They're not at the moment, but like, who cares about the bloat in 2026? I'm happy. I am for my use case. I'm happy to have a larger binary, but newer toys to play with. Define static array allows you to basically use it at context for time, effectively. It's a bit of a... I'm not sure of the intricate of the actual details, but this here will give you a vector of std meta infos, but something using it at context for time is a bit of a pain. So this kind of is a bit of magic that makes it work. It's a bit like, is my understanding of it anyway. I'm sure there's more nuance to it than that. Okay, I'm not going to spend too long on this, but I am kind of curious as to why it doesn't work. This is all chuff, right? I don't care about any of this. This is chuff, 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 chuff. Give me the actual error. Not derived from... I don't think it likes my... Std range is 2. It's a bit of a shame. No, we... Oh, hang on. Oh. See you later, mate. We'll go on. I'd like to know what it's trying to invoke this with. So we've got the span of meta infos, which is what I wanted, into the transform. Just check it's not. Now that I fixed my syntax error. I think that's right. Expected variable name this lambda capture. I don't know why I would want that at all. That doesn't make any sense. The problem is Clang D is not very good with reflection because it's not caught up yet, so it gets very confused. Okay, I'm going to call this... so frustrating because I really feel like this is really close. E is not a constant. E is not a constant expression. Oh, he's not. It's not wrong. Because you can't have context for arguments. So we might be out of luck here. This might not be possible. This might not be possible. Yeah. Because E has to be const expra. Because it's compile time. Reflections all done at compile time. I'm going to think about this for like 2 more minutes. And then I will call it. Because there's no other way to pragmatically build up the lookup table, like, because we could use template expansion or an expansion statement, but I would just be hang on. Right, let's try this. Let's add another lambda. And let's literally take the formatter code that we know works. Right, so let's just, why is that maybe unused? Oh, SideQuest, hang on. Right, and let's stick that there. That's looking better. So now, rather than T, we have physics layer. Okay. Pass that in there. No, I mean, no. Right. And then for each of these, we will do result E, third string std meta identifier of E. I think that will work. So use std meta extract. I'm unfamiliar with that one. Let's get the reflection paper up quick. Oh, there is an extract. Exciting. Let's read it together. If R is a reflection for a value of type T, extract R is a PR value whose evaluation computes the reflected value. If R is a reflection of an object of non-reference, if R is a reflection, where's R in this? If R is, oh no, this is of type T, extract, oh I see, sorry, extract TR as a PR value whose evaluation computes the reflected value. So this is converting the stored meta info back into the underlying value, right? But how does that differ to me just splicing it in here? That's the bit I don't understand. This is... Oh, hang on, it even says it here. Hang on. Whoa. The function template extract may feel similar to splicers, but unlike splicers, it does not require its operand to be a constant expression itself. Interesting. Also, unlike splicers, it requires knowledge of the typeface. Interesting. So you might be right. Interesting. Look up, it's not literal. Yeah, that is. So, but won't I still need it to get the identifier of it though? Won't this still need to be const explorer? I feel like this is not a million miles off now working, which is this works. That's fine. Why is this? Why is this complaining? Sorry, a bit of a C++26 side quest today. It's not literal because unordered map. Is it because I have not included? Do I need to? Okay, we're getting there. So this, I don't think it likes repassing this in here. I'm pretty sure this is all const expert now, so that seems strange. I saw something about the exception. Let me just comment that out for a second. Just get this down to like the bare minimum working, and then we can add more stuff in. Concept is not literal. Maybe it doesn't need to be const expert. I guess it just needs to be static, doesn't it? That's fine. Maybe I'm asking too much. And I'm back to all this like jolt misery. I don't understand why any of this has come from. Like, why am I getting all these static assert failures? What have I done? What have I done to deserve this? Something somewhere has been passed that is trivial. Or there's some concept or type check going on somewhere. Where in my code? Just tell me, where in my code? Is it? I don't know, but it shouldn't matter if it's a member variable, because none of this should be based on the actual physics system itself, right? Like the physics system class is just a wrapper, like nothing, and none of that is being passed into the jolt system. It's just a member variable, right? And members don't have knowledge of their parents. Warning: template structure service deprecated uses. And oh, hang on. I think this is. Is this just an error in their code that it doesn't like compiling under with my modern compiler where I have warnings on? Look, warning. Template class 2 structure is trivial is deprecated. Use is trivial default constructible and is trivial copyable instead. Deprecated declarations in their static assert. Deprecated. All these warnings I'm treating as errors. Oh, what a bloody nightmare that is. Right, this we're going to have to, I think. Yes, I think the issue is I might use meta extract actually, just because I never used it before. That's fun. Nope, not for me. Okay, fine. Side quest, right. Side quest to the side quest. Let's think about this. I need to make sure that their code. How do we do this? We need to make sure their headers are not subject to the same warnings ours is. I need to fix the jolt errors first because it's making everything so much harder to deal with. So let's see. CMake. How do we didn't we have this with async? And did I just disable the warning? I'm sure we had something like this with async. Here you go. Yeah. I can just disable the warning for them. So what's me misery de jure? So I want something like were no error equals deprecated. Should be uppercase J. Oh no, sorry, you're right. It's the library is uppercase J, the target is lowercase j. Well done, good spot. Oh. In which case it must be J if that's the compile option. Let's rebuild the world. I'm glad Jolt's added like another 143 translation units to my project. I didn't quite have enough with async. Gosh darn it. Deprecated declarations. That is right, isn't it? As we definitely do that with here. This is some bullshit I could do without, if I'm being totally honest. It is saying error, though. Is this error because this is actually an error, or is this error because I'm treating warnings as errors? Yeah, so what error? So you have to put with no error to get rid of it. Unless you literally just cannot build this. Let me just... Oh, it's deprecated in 26. It might just not exist. Deprecated in 26. No, it's not removed though. It's only deprecated. It means it probably removed in 29. This should work. I don't understand why this is not working. Unless it's because it's in the header file. It's because it's going to be in the header file, isn't it? I think I'm going to have to copy this. Which I really don't want to do. Oh, well, yeah, I've had to do the same here. Fine. Can't I exclude headers? Like, can't I mark this as like a system header so it doesn't? Hang on, CMake don't warn in third party. There's a way of this is, I'm sure this is solvable. Say warning on fetch projects. Here we go. Okay, hang on. Well, I didn't think we were going on a CMake adventure today. Target include directories. Jolt system interface Jolt source. Hang on, what's the Jolt project look like? Jolt. Oh, what absolute pain in the ass this is. I think it's Jolt source directory Jolt. Do I mark them as system headers? I don't want to ignore all though. Hang on. Oh. ls build depths Jolt source Jolt. So this should have like jolt.h in it. So I don't understand why that. What was the error? Build depths Jolt source. Yeah. Create a header file wrapper. Could that? So, oh, that's interesting. Okay, fine. We might be able to do e source physics engine jolt.h. I really don't like this, but apparently you can do. I didn't know this. You can do pragma system header. And then do utils like that, and then we can do hash include physics. It kind of breaks my philosophy of only including what you need, because it means we'll have to put all jolt headers in here. But if this works, kind of happy just to suck it up. Okay, fine. Let's undo what the other misery we had. So that was, get rid of this. CMake source. Get rid of that. Okay, hang on. Right, okay. It's not apparently not what I want. What I want is util jolt. Pragma GCC diagnostic push diagnostic. Ooh. Ignored W. Oh, this person's even. Yes, this is using the exact same issue. Okay, there's a include that hash pragma GCC diagnostic Pop. Got different errors. Got different errors, which is progress. Invalid application of a line of to incomplete type. Am I missing some types? Have I got to... Incomplete type suggests that I'm not like actually include jolt math vec3. Oh, that's gonna be grim. Where is it including? I need the full include chain. Here we go. Utils jolt jolt.h. Because writing code is fun. This is fun. This right this moment is not fun, but writing code is normally fun. What is all this? Right, invalid application of size of to incomplete type Jupyter vec3. Why? This is all templated, right? Size of t. An instantiation of static array vec3, which comes from physics system, the header, the utils, jolt.h, and then jolt.h includes all, but it includes all of these, right? So I don't understand why. It's definitely got itself in a little bit of a state here, hasn't it? It's trying to export this unit sphere, right? Have they got any? Let's have a quick look on their GitHub. Anyone else had any of these issues? Oh no! Hang on, what's this? Jolt fails to compile. No, what are you talking about? This is exactly my problem. Exactly my problem. I mean, have I just got to upgrade my version? I fixed some other issues, but I believe the error is S-unit sphere is actually a compiler bug in the experimental reflection flag. I've created a minimum example of Cobalt compilers. Great, so it's a bug in GCC. Let's just lock down at the moment. Got the keys, looks like it's actually a bug, and they fixed it. Ah, oh, right. I'm gonna have to rebuild GCC. Oh, this is going to be an absolute disaster, this. Right, let's do... and then... Let's just check it is on... GCC trunk. Okay, fine. So that's... How long ago is this? This was last month, and it's been a while since I've rebuilt this. So let's do make Docker image. How long does it take to build? We'll find out. It takes a non-trivial amount of time to build GCC. We'll just have to sit here and stare at this. Right, let's just... I can hear my fans are whirring. It's not too bad. Got to build bin utils first. Clang takes ages to, especially a debug build. Yeah, GCC for like this kind of like, because I don't think I build it multi-arch. I think I just build it for x86 64 and maybe have some other stuff. It's not too bad, right? It takes bloody ages to clone it though. Right, it's just I want to just see this go, and then we'll go and, I don't know, have fun with the code, look at it. I really hope they fix this. They are, to be honest, because reflection is such a high-profile feature, and because GCC is the only compiler that supports it, they are absolutely smashing out the bugs at the moment, which is good. Okay, we're still cloning, like GCC, like this is with depth 1, by the way. That's how big the project is. I'm not even getting the full Git history. I'm literally just getting trunk. How's the project going? Mate, we've got to rebuild GCC because there's a bug in it. I find that absolutely hilarious, though, that Jolt has a very specific issue, which is fails to compile C++26 reflection. That I find that infinitely funny. This might actually be building it now, to be honest, because I think this, I can't remember, I think these are all chained together with like, the doc file. Can't remember how I did any of this. A lot of this, I will admit, a lot of this file is vibe coded. I found someone's example on GitHub and then sort of vibe coded some extra changes to it. Yeah, so basically it'll clone it, but then it does it all under one run command. So this, oh no, it's okay. We've got the output now. So we're now building it. We're building GC, guys. We're doing it. Oh, interesting. I always thought depth 1 would be quicker because you don't get the full history. Interesting. Build time, I mean, it really depends on what kind of project you're working on and what kind of hardware you've got and the kind of changes you're making. It really does vary. Like, yeah, COS has bad build times and when it does get a bit of a bad rap, but it's not always terrible. This is not a great example, by the way. My normal dev cycle does not involve me having to go and rebuild the compiler very often. Embaru, commit message. Go on then. What do you want? 3 boots. You can have that is unbelievably rude and I hate it, but I will do it for you. That is I really that's really, really rude. Right. I'm not sure because I don't want to amend anything. Let's actually no, I'll tell you what, I'll even have it. We're going to have it on the most trivial change because this is really funny. This one that just adds a couple of empty files. Let's reword this. By the way, what do you want that email address to be? No, that's really funny. I really find that funny. Do you want the email address at the end? And what should I replace the asterisks? Oh. No, stroke again. Asterisks. No, one of them's a cartoon character, and one's a French cartoon character, and the other one's a button on the keyboard. Asterisks. Asterisks. You might need to. I can't tell if you're typing the same thing over and over again because you think it's funny and it's slowly sending me mad, or if you're just being hit by the filter. Hunter 2, classic. I was hoping someone would say that. Hunter 2 is, man, that's some old internet, that. Brilliant. Anthropic.com. I really hate that, but it's really funny. I'm gonna get so much shit for that at some point. Amazing, thank you. I'm gonna turn that off now because I only turn them on every now and then. I don't have those commit message like Twitch things every stream because it just get flooded with them. I just turn them on and off every now and then. Oh, we built Clang. Sorry, we built GCC. We've done it, mate. We're building MinGW now. I used to have to build Clang as part of this Docker file because I tried to munge in some sanitizers and it never really worked. I think I've removed that now. So step 10 of 15. No, it was great. I really appreciate that. That's really funny. That's genuinely quite funny. I also feel like hopefully I enriched the joke a little bit by putting on a really trivial commit. I've been reminded off stream that there is indeed a tithing today, so I'll try and remember to do that before we all leave. I can do that now to fill time. Can I do that now to fill time? Playing for time while I build a compiler. Oh no. No! Don't fail me. Oh shit, I've seen this before. Surely I've not changed the Docker file in a while. Right, this is the stream now. Sorry guys, it's rebuilding my miserable build system. Like, we have to just get on board. This is where the train's going now. I have fixed this before. I have 100% fixed this before. Did I have to change the... I think I had to change the MinGW version. Obviously. And where are we up to? What version? MinGW version. I think they fixed this. Changelog. We're up to version 14. We could try the latest one. Docker's clever, and it will know that the layers we've already built haven't changed, so it shouldn't rebuild GCC. It should just jump straight to step 10 and 15. Oh, I nailed it. Nope. Nope, it's redoing everything. Great. Oh no, piss off. I'm not having to rebuild GCC again. That's rude. Why is that? Is it? I thought. Oh, it's because it's. Why do I make the directory? So the first thing I do is make the MinGW directory, and then I do everything else. This should move down because it means everything after this is now effectively changed. I thought it was only the run commands that changed because notice it jumped straight to 4, which would be this one, right? I guess. I mean, how many times can you build GCC in a stream? If this doesn't work, I don't really know what the solution is. I guess like, what do I do? I can't not use Jolt, but I can't just cry. I think I just have to have an absolute breakdown. Because like, why am I building it? Because because my friend, there is a bug in GCC that prevents me building the physics engine I want to use with the specific set of flags that I need to use, and I'm hoping that by rebuilding the compiler on a more recent version, they would have fixed that bug, which has been alluded to. That case has been alluded to, but now I just have to play for time and realize that I'm actually kind of bad at improv. So the other thing is we build it separately, yeah. But I want everything to be. I like a unified build system. I want CMake to drive the world. What is the bug? Uh, a compiler bug in the reflection flag. Here. Compile with reflection is instantiating the array template at the point where mdata is declared. It's too early and should not be instantiated to mdata implemented in the last line, which is what we've seen. And they have fixed it a month ago, but I've not rebuilt. It's been a month since I've rebuilt GCC, so it was a reflection flag, yeah. I mean, there are solutions. I'm being a little bit dramatic. There are definitely solutions to this, and we'll figure it out. We'll get some. We will definitely get jolting, and still be able to use reflection. But for now, we might as well rebuild GCC again. And then I will just think really hard about my life. I mean, that and the project. We're just on many a side quest today. I did say at the beginning we weren't going to get much done. I suspect MinGW will still fail after this. Although I can't understand why, because I've definitely been building and using this before. Like, we've been using this Docker image the whole project, so I can't understand why 13 would suddenly fail unless it doesn't play nicely with GCC, but that shouldn't make any difference. Why would that have failed? Don't know. When did 14 come out? It came out at the beginning of the year, so 13 came out before I started the project, so that probably was the latest when I set up the Docker file. Just looking at the patch notes if there's anything. Nothing mentions in the note. It's like notable changes. Various fixes to stat, Mustakwas and Mustakums, MinGW format, 23 half revolution trigonometry math function. I mean, finally. Sync Y 11.5. None of this mentions this specific case. It does all say other things. Have they got like an actual patch notes? Ugh, no, go away, don't care. Oh well, we'll see what happens. We're MinGW building again. No, std format's been there since 23. Std format's 20. Print ln is 23. Can't remember. I do have. What have I got? I've got the tool chain. I don't think I set anything particularly fancy with it. What compiler were you using, I guess? Like, what version of what compiler were you using? Is it working? Is it not? Did we get this far last time? Did we not? Do we hate everything? Yeah, I mean, I do have quite a beefy PC, so it'll be massively parallelized. I'm right there next to you, mate. We're all in this together. Yeah, but Docker only uses the Docker image that WSL runs under, or whatever it's WSL only uses up half my RAM, so at least there's at least half of it available for streaming, and the GPU won't be involved in the compilation process. So I think we should be all right. Gosh darn it. Same issue. I'll probably have to fix this off stream because this is no fun for anyone. Does anyone actually... So someone says they've patched this and they pushed it. Hang on. Oh, right. Hang on, what's this? Stat check guard type, right? They pushed this. This patch looks good to me. I've pushed it to master. When was... hang on. So 20. This was pushed after this release. So now I need to work out how to do a out of how do I build master? What CPU do I have? Give me a second. I have a AMD Ryzen 9 9950X3D 16 core. I brought quite a beefy PC before the RAM prices absolutely skyrocketed. I'm trying to. Well, I've built it twice now. What I can't do is build Minji W. Right. Where do we pull Minji W? What option? Can I access master? It's only got version. Okay, I'm gonna have to look at how you build MinGW from completely from source, because we could ask the Clanker, because they only have that's under releases. There's snapshots. I probably want snapshot, right? No, because that's version 1, 2011. I definitely don't want that. I am unsure what to download. Yeah, but it's not Git though, is it? Like, isn't... I suppose it is just on SourceForge. Where's the... Here we go. Here we go. Right. Let's try... I think we should build this, bring this up before we build GCC now. Right, now... Oh no, it is done. Right, okay, fine. Why do we not build that? Or does it build it with GCC? No, it just uses the built-in one, doesn't it? Let's... CDs... Do I build... Whoa, why am I building GCC twice here? Then, if its version is trunk, get the clone, else do that. Then make that, and then... Yeah, I think... And then CD into GCC and make it again, I guess? What? And what? Oh yeah, what is this? What is make or make or make or make? Okay, fine. This needs some cleanup. I don't know why this is happening. Right, this is bullshit. Get rid of this shite. Okay, this I think is also bullshit. Get rid of that. Let's move this up to where we actually clone it. Right, Clank is not ready. It's not ready for mainstream use yet. I thought I'd give it a go with this, and here we are. Okay, so let's get clone. Hang on. Git clone that into this, right? So then I should be able to see. Why would I make what? Oh yeah, right. CD into that. And then what's going to be inside of here? I need to get into the headers file. So I think I then just do. Why is it then CDing back out again? Right, this is. Oh, hang on a minute. It's one of these like the build. Actually, I might want that. Stick it into that double one. Make that one. Go into that. Go back out. Yes, 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 yes. I see what it's doing now. And then do, because I don't actually now have a version. I just have the header of it. MinGW64. And then into there, because I've got the Git tree UI thing off screen. So that goes the headers, that configures bish bash bosh. We give it a go, and then I remember I had to do something with libp threads separately, so that might be why I need that. I think I didn't tell it to. I think I forgot to say don't make any mistakes, which is in my hubris the issue. make mistake. Okay, well we're cloning that, so that's clearly something. Okay. What did you not like about that? Failed to process. This problem did not complete successfully. There you go. What's this? MinGW. Oh, I still got this, right? Where's it? Ah, that'd be here. Can't believe I'm building master. What am I missing? What am I? Yeah, it's definitely progress. What am I missing though? It can't. It's trying to build the threads, but it can't find Windows.h, which suggests that it's missing something from the previous step. So that's pretty straight up change. This is so funny. Oh, hang on. I probably actually need to make this first, right? Before I install it. That's probably why I can't find the Windows.h file. absolute shit show. I do apologize. This is not the stream it's the stream we got, but it was not the one I planned. This is real engineering, right? This is like shit's broken, something's updated, and we gotta pull in, like, you know, we got to pull in something upstream, but it doesn't now work with something else, and like everything is a disaster. This is it. This is the job. And sometimes we just keep running make until it works. I can't believe that. I can't believe I never even spotted that. It's so funny. This is true, yeah. Clang doesn't support reflection or any of the C++26 stuff that I want to use, at least want to use now. Why is it not finding windows.h? I'm missing something. What am I missing? So this should have installed it there. Yeah, I'm wondering if we do need to. What I might do is let's just. What if I just remove that for now? I just want to just, because it clearly builds MinGW, right? I just want to just see if we can keep going. I think you deleted the CRT. Oh, did I need to build two so I could build the WinP threads? Is that what I did? Is that why I had so many of them? Ah, yes. Here we go. This is why I needed this one before the P threads one. Can I? How do I get access to this? Nope. Let's just open that link. Didn't want to do that. Thanks, mate. Is that? Nope. I'm gonna find it. Hang on. Hold on one moment, caller. So what are we at to now? We're at to min GW W64 slash min GW, right? And then I probably don't need that many makes. If I'm being totally honest with you, do not need that many makes. Also, should this not be make genproc? Please check the header set and build host options and set properly. Yes. Have I got a pathing issue? So we clone it and we build the headers. We then build the CRT. Yeah, this is an absolute pain. I don't understand why this is failing. Please check headset and build options are set properly. They are, because I feel like I must have a typo somewhere. Build headers, build CRT, build WinP threads. Yes, that's what I'm trying to do, right? So I've cloned it. Oh, hang on. No, 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 no. That's... What am I missing? I don't understand. So it goes into the directory, it then goes back out into the cloned one, which is the MinGW64, MinGW64. So good, we named it twice. And then that goes into... That's definitely got the CRT configure, haven't I? Yeah. MinGW... I don't understand, because this... If I did this... Error, please check the set properly. Like, surely it's not the fact that I've got that, right? What did I have before? The only other difference is that it did it after building GCC, but I can't see what difference that makes. Also, this doesn't have the... In my original one, I didn't have the make it. I literally just called make install. And make and CD and configure. Prefix user local OS for WT2, host that, enable SDK all, and make install and CD up. Then build GCC, which I don't really want to do now. Then CD back into MinGW. We could probably make it so we don't have to keep jumping in and out of this directory, but at the end of the day, who cares? Configure, prefix, user local, that, and make... Like, surely the answer is not that. No, thank God. I could clean the cache and rebuild the whole thing. It's just a massive pain. Also, I don't want to accidentally remove, because I've already got like the old one built, which I know it doesn't build Jolt, but at least I can build stuff at the moment. Other than that, I don't want to accidentally remove that. I cannot be removing my Docker image whilst I've got a buggered Docker file. Yes, I know I had them in. I can't see what. I mean, might as well go back to that. So D6. I guess we can put that here. I guess it just doesn't mean we now have to build GCC again to see what happens, which is what I was trying to avoid. This is deeply upsetting. Always be defenestrating. ABD, always be defenestrating. Make is the is the Clanker output that when I used it to help me build this Docker file and I hadn't noticed. I'm kind of tempted to leave it in because it's funny, but it will be replaced with the proc when I check it works. It just really, he's gonna make or make it. Make or break it. This is the last run because I will just expire if I have to spend any long doing this, and I might need a fresh look at it tomorrow. I'm glad you're all enjoying my misery. I'm somewhat hoisted by my own petard, right? Because I did choose to use the bleeding edge of everything. So this misery was inevitable. It was inevitable. All 16 of my cores are now 100%, so it's really building GCC real hard. I just can't believe it. To be fair, also, I'm surprised we haven't hit a reflection bug up until now. I'm not even using modules. But yeah, we were playing with fire a little bit. It's fine. I'm absolutely convinced we'll get this working. Like, this is not the reason this project fails. No, that's fine. Yeah. Well, we got to be reflecting. Surely not. Surely not. Like, surely not. I don't understand. Why would it make a difference if GCC is built or not? My pitch is getting higher and higher as I'm getting more and more frustrated with this. And this isn't parallelized. So this is make. I might fix that. So funny. Oh, all this just so I can build Jolt. Jolt doesn't even use reflection. Like, Jolt does not even use reflection. It is C++17, I think. I think the minimum GCC version is like 12 or something. No, probably even or 11. C++17, GCC 12, Clang 16, or VS 2022. Still got to build WinP threads after this. Well, we've already built it, and we're only up to 5 minutes, and we spent most of that in the non-parallelized MinGW build. So I didn't. There you go. It takes 197 seconds to build GCC, which is not bad. Could be worse. That includes cloning it, I think, as well. Will I make a video about this project? I'm like, it's not normally the kind of videos I do, but I'm kind of tempted to maybe just do like a deep dive summary of all the different parts and do a bit of like a code review. I am tempted to do a video on it, even though it's not my normal kind of content. Like, that might be a little bit, but I might indulge myself. it's now taken longer to build one part of MinGW, almost as long as to build this one part of MinGW as it is to build the entire GCC. And I know it's not because it's not parallelized, but still. Got over 200 people, like, and so this is a high number viewing today. Over 200 people across both platforms have watched me failed to build GCC twice. Actually, failed to fix my build system twice. It's good to talk about. Is that you talking about therapy? Like, is it good to talk through these issues I'm having, or it's good to talk about the project? What's the most esoteric thing in C++? Trigraphs were removed, weren't they? Or was it just digraphs? I thought one of the two was removed. I thought they were deprecated. Trigraphs were removed in 17. Also, well, actually, on this page though, I do think one of the more esoteric parts of C++ is that you're allowed to use these keywords instead of the symbols. So you are well within your right to do this, and also any of these, if you so choose. I choose not to, but like you can. If you want to write not ec, be my guest. That's an esoteric part of C++. Oh, we're up to WinP threads. Ho, ho, ho. No, once this docker image is built, I can use it. It's just getting the bugger to build. Yeah, I'll fully parallelize this now. And see all my cores are spinning. I think pthreads did fail, yes. But this is just doing the configure stage. I can see this is auto tools, right? It's not actually building anything yet. This is just checking that I have an int type. Right, now it's building. This is really tense. I mean, that's why I wanted it all Dockerized, right? Because like once you've got that Docker image built, it's the same every time. Right, and it's reproducible, and I just push that up to GitHub, and then all the CI users are, I'm going to push this up to GitHub, otherwise the CI is not going to work. I thought I was using it was the latest version whenever I built the Docker file, so I've just not updated it. I don't think there's anything beyond the 4.1 that I need. Because this Docker image contains everything. It contains the compiler, it contains CMake, it contains the build utils, it contains MinGW. It's everything that you need to build the project. Yeah, but it's just like we're just gonna power through. Like this is people are here and they're enjoying it. I don't know why, but people are here. Let's do this. Oh, we're exploiting layers. Oh, we've done it. We've built a Docker image. So now the question is, can I now build my project using this? I need to update my header files as well. Because ClangD needs access to the GCC header files within the Docker image, and that's a massive pain to do. So I have a separate make step which copies them out of the Docker image locally, but they get ignored, so ClangD can find them. God, it's a lot of layers to export. Like, I'm pretty sure it can't fail now, right? Like, it's built, it's done the layers. Onions have layers. Docker has layers. No, I gotta commit. I gotta be positive. It can't fail. the theory is that once I've built the Docker image, I have a reproducible build system that just works. It works on my machine, it works on the CI, it works everywhere, and it has everything I need. It manages all the dependencies. It's literally using Docker for what it's meant for. That's the dream. And in theory, it's then easy to upgrade. It means that when I want to upgrade GCC, I don't have to have a load of local versions of GCC on my disk. I just upgrade the Docker image. Why is it uploading it to Docker.io? I don't remember telling it to do that. Oh, I've got like a 4 terabyte hard drive. I don't think I'm running out of space. Again, built my PC before SSD and RAM prices shot up. Stressed. Right. Let me just sudo rm rfsysroot. Let's check that's in here, not just some random sysroot. Make sysroot. I'll just copy those out. Oh no, it's moved. Oh no. Anyway, let's just see if I can build it first. Something's changed. Oh, that's not good. That is not good. I need to get my sysroot files back. What are they called? Docker. Hang on, I can't remember what I need to get into the shell. Hang on, give me a second. Docker exec, that's what I want. Docker exec. I mean, I just built it. Did I not just build it? Oh yes, you might be right. Hang on. 1 second. Oh, it's not going to work in fish, is it? Hang on. Right. Okay. Hang on, I've done this before because I had to debug this last time, so it's definitely my history somewhere. I will find it. Give me 1 second. Maybe I just need it without all this gubbins in here. Docker run it. Docker run it rm custom bin gw64 bash. There we go. Whew, well done. Why was I doing this? because it doesn't like user local x64-w. Why is it not like that? What was the actual issue I was getting? Cannot stat user local x86 includes C++. It looks like it's messed up the orders somewhere. It's installed something incorrectly now. Why are all these? This should be in a C++ directory. Yeah, so I think there's a few things to unpack here. One is like, why is... I should have a C++ directory in here. So that probably is why it can't find the headers in the build. So why is this... Why is this changed? This would be the GCC headers, right? How sorry, can I, if I got find? Oops. Sorry. Find root type f name iostream to dev null. Yeah, it's not got the C++ headers in here, right? So that's part of that's problem one. I think I might have to call this and figure this out in slow time because this is weird. I'm sure these should be here, so I'm trying to work out why this is not. Oh, type D. Oh, thank you. Sorry. There we go. User. Oh, it's put them somewhere else. Fine. It's put them in user include C++ 13 vector. So that. So does that now change to user include C++? User include C++. But why does it not put them in user local? I think I'd rather they were in the old place, I guess. I don't know. I think I need to go and because this now is definitely saying it can't find that. Just trying to see if I can see where it's searching in here. I feel like it's not got the system includes anymore. Very strange. Did CMake cache? I mean, we could do a clean build. I can't. Well, I've thrown it all away now. Cannot find. Ah, no. This is miserable. Yeah, it's definitely not put it. It's definitely changed the thing. I'm gonna go and do this slow time, I think, because I'm trying to think. Is there anything obvious we would have changed? Shit, is it this extra rando GCC step? I bet it is. I bet it needs that. then it needs that. One last chance to dance. Maybe the clank was right all along. Well, it should only have to do this one now, so let's... This is the extra GCC step now. Is it rebuilding it again? Well, we know it's quick, so it's fine. I'm going to give out membership gifts whilst I'm waiting. There you go. Hopefully your day is better than mine now for 5 people. So yeah, 1 month's membership for free. There is a new video. Sorry, I'm working on the next video at the moment. It's gonna be good. It's gonna be interesting. It's really fascinating. It should easily be done this month. Couldn't tell you when, but at some point. So I don't know, hang around, I guess. I really need to get an early night tonight as well, so that's straight out the window, isn't it? I just want to get this. I need to see it. Right, it's got rebuild CMake again, obviously. Why not? I probably should have put the GC step right at the end. And then it's going to have to export the layers. 87 seconds to build GC, though, is not bad. Which episode are we on now? That's good. Let's play for time. Good one. We are on 38. Come on. It does, yeah. So I was saying I should have done the GCC thing underneath all the other steps. So rather than them to redo 13, 14, and 15. But here we are. Well, it should all be cloned. They shouldn't be doing any more cloning now. Actually, no. I think just wgets specific versions. Oh, come on. Yeah, I think we started it. Was it like November time? When's we can find when commit number 1 was. I think. Is that 300 commits? It's not bad. Oh no, 528. Never mind. Initial commit was Sunday, November 16th. All right, come on. Let's export those layers. Let's do it. This has been an absolutely wild ride, and I'm gonna have to put a hard stop after this if it doesn't work. Right, let's just try make sysroot. That's promising. Make config. getting there. It's getting there. Got to do a fresh, clean build though. I'm tempted to sack off fetch content in CMake and just have them all those files just checked in, so I don't have to every time I do a clean rebuild clone it. It seems like a massive waste of time because also the CI has to clone it as well. Like files are free, right? I might as well just check them all in. Okay. Only 477 translation units. Oh, let's go. I just don't like submodules. Although I do use them in one aspect in this. But I do agree, separating it is like important. But I probably just check everything in because I've effectively pinned the versions anyway. I might as well just bring all the files along. Right. Let's get into the Jolt stuff. I think we hit a different error. Native encoded string. Why am I still getting these? Well, this is in my code now. Oh, they changed file system. Interesting. Oh. Is that because we had this issue before where path was returning wide strings? I wonder if they fixed that. Yeah, I didn't know that was coming in 26. Interesting. Well, we might as well look that up while we're here. It's going to be in a few places, this, isn't it? Graphics utils. The graphics utils? LCP. What am I looking at? Third file system path. Turns the native version of the path. Oh, why no? Anyway, sorry, getting distracted. Let's finish this. File resource loader. File resource loader 103. Was it native? What was it? I don't know why it's not correcting it for me. Native encoded string. I've lost where I was now. Hang on 1 second. File resource loader. Native encoded string. we're slowly getting there. We're getting there. File resource loader 34. Okay, hang on. String. Need to encode string. Ooh. God damn it. Anywhere else? Anywhere else? Hang on, I still gotta make the resources. This is outrageous. This. Right. Are we back to where we started at the beginning? But with a whole new world. It's gonna be worth I'm gonna be really tired tomorrow and it's gonna be absolutely worth it. Come on. Come on, I want to go to bed. This has been a journey. This has been an absolute wild journey. Come on. Write this fucking resources. Come on, chop. If this is hanging because of some other latent bug now. Worried this is frozen. No, whew, right. We're back. I'm so wired now. I'm not gonna be able to sleep. This has been absolute. fixing prod issues at nearly midnight. This is what this is. And it cleaned the ends, right? Let's. Didn't mean to run updates on Vim there. Okay, cool, thanks. Right, let's. Right, okay, fine. So we've got that. Hang on. Let's do this. Fix miserable Docker file. That. Make C++26 conformant. And this is start of jolt work. All right, and where we at? Stream 38. Stick that in the git hole and get on with it. No, I think we still need the jolt header stuff because there's still deprecated in that. It just wouldn't build it for. Okay, I am. My head is going to explode. I've lost so much hair this stream. Like, I didn't know I had that much hair to lose. Right. Well, what an absolute journey that was. I hope that was fun. Like, it was. I actually enjoyed that because I would have to solve that anyway, and it's kind of fun hanging out with people doing it live. But yeah, that was wild. That we did it though. We did it, right? We found a bug in GCC. We rebuilt the build system. We had to then update something else. We fought with Docker. The fact that you've now characterized that entire suffering as we can now reflect two enum values, I find really funny and really upsetting. Nah, mate, I'll remember next time. It's all up here. All the comments are up here. No, I probably should go and add some comments. You're right. Right. I've had enough in the nicest possible way. I'm sick of this and I want to go and do something else now. So I will see you all Wednesday, where we will maybe write some more Jolt code or we'll rebuild GCC. We'll just see how it goes. But I will see you all anon.